Okay, so we talked about the comparative statics, and we looked at an example. In the current slide, is basically the same thing that I have done in the last lecture. So you can check it yourself. So yeah, so from now on, so we talked about what a model looks like. So model has two components: exogenous variable and the endogenous variable. And so exogenous variables are the values of certain variables that are set irrespective of the model. And the endogenous variable, the value of which are determined in the model. Okay, so that's the basic. Model, and we're gonna use this kind of model in the next 3 years. And here's a consumer theory. So we are going to develop a theory of an individual choice. So how the individual chooses, right? And that this will provide the foundation for market demand curve and the foundation for labor market supply. I probably should have explained what the course is about. So let me talk about that a little bit here, and then I'll continue with the consumer theory. So roughly speaking, yeah, so the main two thread of the course is the consumer theory and producer theory. Okay. So from the consumer theory, we're gonna derive the demand for the goods. Okay. So we're gonna derive the demand for the goods, but at the same time, the consumers are supplying the labor, right? So we're gonna choose. We're gonna see how the consumer chooses how much of labor to supply to the firm or to the market in general, right? And for that, we will need constraint constrained optimization of the consumer. So consumer optimization is a special case of constraint optimization. And using the producer theory, we are going to derive the supply for goods. Okay. And we're gonna also derive the demand for labor, or in general input factors. Okay. All right. So producer theory is can be characterized as a special case of an unconstrained optimization problem. Okay, and here, so using the demand for the good and supply of the goods, we can derive the demand of the consumer and the supply of the firm, and characterize an equilibrium. Or no, not this one. Let's see. I have to do this way. Yeah. Or using the supply for the labor and the demand for the labor, I can characterize similar phenomena in the labor market, or in general input factors market, right? So that's gonna be an objective of this course. So basically, we are making a foundation. We're describing a foundation for the demand curve and the supply curve from an optimal choice of a consumer and an optimal choice by a producer. Okay. Then these graphs are just looking at one particular market, and then we're going to generalize it to look at all the markets at once. So that's called the general equilibrium theory. So that will be another objective of this course. Then we're going to look at some externality issues, right? So yeah, so that's gonna be the last theme, last major theme of the course. Okay, so that's gonna be the objective of this course. All right, so for the next 3 or 4 weeks, we're gonna develop the consumer theory, and as I mentioned in the last lecture, this is the most important part of this course because this is gonna be the basis for everything. So if you don't follow the first 4 weeks, then you will never follow the rest of the lecture. Okay, rest of the course. So you really need to master the first 3 to 4 weeks of this course. Okay. All right. So consumer theory. So consumer theory is so I can roughly divide it into two parts of the consumer's optimization problem. So the first is what a consumer wants. Okay, so maybe what a consumer wants and what a consumer can do. Okay, these two are very distinctive things, right? So I mean, of course, I want to do many things. So in terms of what I want, there are many things. But in terms of what I can do, that's a different matter, right? So I have a limited time, I have limited income, I have limited I don't know, talent. So in terms of what I can do, there is always a restriction, right? So by describing these two things, what the consumer want and what the consumer can do, and then put these two things on the same page, an optimal decision will be derived. Okay, so we'll see how it comes out. Then we use the comparative statics to analyze how the individual's behavior changes when an outside environment changes, and one of the major objective of our course is deriving a demand curve, right? So demand curve is given by what's the demand curve? So demand curve describe for a given price how much I consume, for a different given price how much I consume, and for another different price how much I would want to consume, right? So basically, demand curve is a response to a price in terms of your choice of quantity of consumption, right? So in that sense, this can be understood as a comparative statics. When the price changes, which is given by the outside of the model, how much you're gonna consume, right? So we're gonna do that. All right, first, what a consumer can do, wants to do, right? So for the time being, we're going to assume that a consumer always wants to acquire goods, right? I mean, of course, this is not true in general. So, for example, if you think of the garbage, or if you think of, let's say, pollution, or anything that's painful for you, you actually want to avoid it instead of acquire that, right? So, so this assumption is not 100% natural for all the commodities we can imagine, but for the time being, we're gonna stick to this assumption. And once we understand the consumer theory under this assumption, then we can relax this assumption and see how the analysis changes. So actually, once we do the analysis under this assumption, it's very easy to change this assumption to commodity that you actually do not want to acquire. Okay, so for the time being, let's stick with this assumption. Okay, so we'll get to this point of relaxing this assumption to describe a commodity called bads later. Okay, all right. So goods can be anything that the consumer wants. So typically, we always think about the consumption products, consumption goods, but it doesn't have to be a consumption good only. It can be a financial products, so which is I don't know, let's say stock or the combination of the stocks. So for example, you can think of an index fund or something like that, and it doesn't have to be a product only. It can be a, say, financial service, right? So you can get some advice from someone about how to manage your finances, right? So the service can be a good as well. So for example, when you take a taxi, you're basically buying a service, right? But the service can be understood as a commodity as well. So I don't know, in high school, the textbook is trying to differentiate between service and the good, but in terms of consumption theory, the distinction is not so clear anyway. Location. So location can be also a choice. So for example, whether you're gonna live in Seoul or live in Busan or somewhere else, this is the result of an individual choice. So it can be understood as a consumption good as well, what the consumer want. And good weather. So you can choose a good. So in terms of choosing a location where to work or where to live, weather can be a factor, right? So I did my PhD study in California, which has excellent weather, and after finishing that, I had to choose whether I go back home in Korea, or I can get a job in England, or I could get a job in California. So if I choose a job in California, the weather must be a really good thing, right? So the weather was really nice. I know maybe it's too dry, so maybe it's not so good for your skin, but I didn't care about the skin condition that much, and I still don't much. So anyway, so I could choose this excellent Los Angeles weather, or I could come back to Korea, which is like 4 seasons. But in fact, it's only 2 seasons, like freezing cold or it's really hot, right, and humid. Or I could choose go to England. So England is infamous for this rainy weather. But the choice of weather is not independent, right? So if I got a job in LA, it could have been a crappy job, and if I come back to Korea, I should have worked at a company instead of at a teaching institution. And if I choose to go to England, I could work at a university. So your choice is a combination of everything, right? But one of the components can be a weather, right? So my choice was choosing a bad weather in England, but choosing a university job in England at the same time. So I went to England and worked there for 5 years, and then I came back to Korea. And in good health, yeah, that can be also choice, right? So if you choose a job that deals with toxic chemicals, maybe it's not so great for your health, but that's your choice. Okay. All right, and then here, so as I mentioned here, we're assuming that I said that we're gonna assume this one, but we can also account for different things called bads that consumer do not want. But we're not gonna talk about this one for the time being. But we'll talk about this in a few weeks. Okay. So for the time being, we are assuming that consumer always want to acquire goods. Right. So that's what the consumer wants to do. So we're gonna introduce new concept called preference. So because a consumer cannot get everything that he or she wants, that's the what the consumer can do that will be described later. he or she must be able to decide which goods to get and which goods not to get, right? So we are going to assume that a consumer can rank all possible combinations of goods available in the economy, okay? And the bads when we introduce it later. So from now on, we're gonna think everything in terms of bundle, not as a good. Okay, so let's say for the time being, say there are L number of goods. Okay, so L can be any number. Say L can be 2. If that's the case, then we have only 2 goods in this word. And L can be, say, 100. That means we're gonna have 100 kinds of goods in this word, right? So remember, we're dealing with a model. Model is not the same as the real world. Model is a simplification of the real world. So depending on what we want to analyze, I can assume L is 2, or I can assume L is 10, or I can assume L is infinite, right? So for the time being, we're gonna assume that L is a small number, okay? All right. And we're gonna so we're gonna think everything in terms of bundles of a good, okay? So when we think of a bundle X and Y, this will be an element in the Euclidean space of L dimension, okay? So if, for example, say L is 3, then X is X1, X2, and X3, and Y is Y1, Y2, and Y3, okay? So let's say this is apple, bread, and the cider. Okay. So if is written as 3 to 5, that means you're consuming 3 apples, 2 units of bread, and 5 bottles of ciders. Right? And if Y is, say, 1, 4, 2, that means 1 unit of apple, and the 4 units of the bread, and 2 bottles of a cider. Okay, so this is how we think of the choice or the goods in general. So we're going to think everything in terms of a bundle. Okay. So as an economist, from now on, you cannot say you like jjajangmyeon more than the jambon, right? So basically, you cannot say I like black noodle more than the red noodle. You're not allowed to say that. All you can say is that I prefer 1 unit of black noodle, comma 0 unit of the red noodle, to 0 unit of black noodle, comma 1 unit of the red noodle. Okay, so everything is gonna be described in terms of bundle, never as an individual good. Okay, so you cannot say I like scone more than morning roll. That's something you cannot say. You should say that I like 1 unit of scone and 0 unit of a morning roll more than 0 unit of the scone and 1 unit of the morning roll. All right. So everything has to be described in terms of a bundle. All right. So so here so completeness means that any 2 bundles can be compared. So either you prefer X to Y or you prefer Y to X. So this wavy line is describing an indifference as well. Okay, so when you say I prefer X to Y, that means I prefer X to Y weakly. Right? So for example, in the sorry. So let's say you say 3 is larger than 2 in real number system, right? Or but you sometimes use this notation, right? So in this case, both of them can be 3, right? So in this case, we say 3 is larger than 3 weakly. This means 3 is larger than 2 strictly, right? So this is called strict inequality. This is a weak inequality, right? So the same kinds of terminology is used for the ranking of the bundles. So this means that you prefer X to Y weakly, and this means you prefer Y to X weakly, right? But remember, this is not the inequality in the numbers, okay? This is preference over the bundle, okay? So anyway, so completeness means that any two bundles can be compared instantly, right? So you never hesitate, okay? So you never hesitate. It doesn't take you 1 second to decide which is better than the other, okay? You can just instantly tell which bundle is better than the other, right? So remember, we're talking about the bundle, not a good, okay? And the transitivity assumption is if X, if X is weakly preferred to Y, and if Y is weakly preferred to Z, then Y is weakly preferred to Z. X is weakly preferred to Z. So that's the transitivity. All right. So let's say so I'll give you an example. So let's say so suppose there are only 3 commodities. That is beer, wine, and soju. Okay. All right. So let's say there are only 3 commodities. So 100 means that a bottle of beer and no wine and no soju. And let's say you prefer a beer to a wine. Okay. So technically speaking, I'm not allowed to say I prefer beer to wine, right? I should say I prefer 1 unit of beer, 0 unit of wine, 0 unit of soju to 0 unit of beer, 1 unit of wine, and 0 unit of soju, right? So technically speaking, I should say that, but let's say in everyday's language, I sometimes say I prefer beer to soju, wine, right? So I prefer beer to wine. But at the same time, I prefer wine to soju. Okay. So that means using the transitivity, I should prefer beer to soju. Right? So that's the transitivity. But of course, we always see weird person, right? So I actually have a friend who used to say that I prefer beer to wine, and I prefer wine to soju, but somehow I prefer soju to beer. So this is violating the assumption of a transitivity. But sometimes we can see this kind of persons, and moreover, when we are collecting individuals' preference to have a preference of a society, sometimes we can see a case where the transitivity is not satisfied. Okay, so this assumption of transitivity is not without the debate, but for the time being, we're gonna assume the transitivity because I don't know, like economist has developed so many cool things under this assumption of transitivity, so we're gonna keep it for the time being, right? And there is always this trade-off between assumption that's only 99.9% correct and getting something good result, cool result. But if you're gonna stick with a really, really stringent assumption, then you sometimes don't get any result. So in that sense, modeling is a kind of an art. So you need to balance how stringent the assumptions are and what kind of result you get. Okay, so at least in the second year microeconomics, I'm going to assume that the transitivity is valid, right? And the reflexivity is that any bundle is as good as itself. So this is a little more like a technical assumption. So I'm not gonna pay too much attention on that. Okay. And many times we are also gonna assume non-cessation. So non-cessation means that cessation means satisfaction. Okay. So we're often assuming that you never have enough. You never have enough. So this is the assumption of non-cessation. So there are two kinds of non-cessation form. I mean, I'm not intending to differentiate the two too much, but so in this a strong form, adding a little bit of any good makes the consumer strictly better off. Adding a little bit of any good never makes the consumer worse off. So you feel like I'm saying the exactly same thing, but I'll show you later that there's a very delicate difference between the two. But for now, let's not focus on this detail too much, okay? And we have this concept called free disposal. So in other words, if we assume that throwing away certain things is free, then we say that we have a free disposal assumption, right? But of course, this is not true in the real world all the time, right? So for example, when you're thinking of throwing a large furniture, when you throw large furniture, what do? Can you just throw away on the street? No. If you do that, you're gonna be fined. You're gonna get fined from the government, it's local government, right? City office. So when you throw large furniture, you know that you need to get permission from the city office, and you have to pay for that, right? So getting rid of a large furniture is not free. You actually need to pay for that, right? So this is related with this concept of the beds. So we're gonna talk about that later. But anyway, but suppose we have a free disposal. So let's say you can throw away anything for free. That means non-cessation has to hold, right? Because a weak form of non-cessation at least has to hold. So in other words, if you think it's too many of the good, you can just throw it away. So in other words, without hurting your happiness, right? So if there's a free disposal, then weaker form of non-cessation should hold. Okay. So we'll see the details what this means later. Okay. All right. All right. So now we talk about the indifference curve. So what is the indifference curve? If preference. So let's say. So for most of the time, we are going to assume that there are only two goods. All right. And if I need, I'll assume otherwise. And whenever I assume that L is different from 2, I'll say it aloud, okay? I'll make an explicitly comment that L is different from 2 when it is not. So anyway, so when L is 2, we can think of the first good in the first axis and the second good in the second axis, right? And let's pick a point. Okay, so let's say this point is 1, 2. So what does it mean? So that means I have 1 unit of the first good and I have a 2 units of the second good, right? So remember, we're thinking everything in terms of a bundle instead of an individual commodities, right? So 1 comma 2 is a bundle I have, right? Now suppose I take some of your second bundle, okay? So let's say 1 comma 1.5, okay? So I took the half unit of the second good from you. And what's gonna happen? You're gonna be less happier, right? So I just took some of your commodity, especially the second good. So that makes you less happier. But instead of that, let's say I give you more of the first good. Okay? So moving to the right hand side will mean that you get more of the first good while having the second good at 1.5 unit, right? So from this arrow, from this first arrow, you're gonna be less happier. But when I'm moving to the right hand side, you're gonna be more happier, right? So maybe I can make it a bit larger, right? So say when you're indifferent between 1.2, so let's say this is the bread and the water. It's just a boring example, but let's say that's the case. So say when you become indifferent between 1 comma 2 and the new bundle, right? Okay. Oh shoot. Okay. All right. Say when of course I cannot say I cannot hear you what you say. So yeah. So suppose you stopped when here. Okay. So that means say this is the point where 2.1 and 1.5. Okay. So that means you're indifferent between these 2 points, right? 1 comma 2 and 2.1 comma 1.5. All right. So as I increase the first goods units, you become happier and happier, and when it hits 2.1, you become indifferent between 1 comma 2 and 2.1 comma 1.5, right? So that means so I can do this exercise for all the points I can imagine. So so suppose I do the same exercise here. So that is, say, 1 comma 1.75. Okay. Then let's say you got this point here. All right. So I can do all the intermediate values here, right? And do that, and then I got all these points, right? So eventually I should be able to draw a line connecting connecting all the bundles there you are indifferent among, right? Right. So you should be able to do that. So this is called indifference curve. Okay. So indifference curve is a set of bundles between which the consumer is indifferent. All right. So maybe I should use among instead of between. I know that is my high school English. So anyway, so you need to. So indifference curve is the set of bundles. All a set of all the bundles between which you are indifferent. All right. So that's the indifference curve. All right. So here, say this is the 2 comma. So this was 1 comma 1, right? So this is 1 comma 2. And you could draw an indifference curve passing through 1 comma 2. But we can think of different points, say 3 comma 1.9, okay? But you can draw another indifference curve passing through 3 comma 1.9, right? I mean, of course, it could be the case that some points are indifference, some other bundles are indifferent between 1.2. So let's say this was, I know, 2.1 and 1.5, right? Or we can think of 3 comma 1.0 or something like that, okay? So in fact, there will be many indifference curves, right? So as I had just explained, with the non-cessation, so in other words, you always want to have more. So that was the, roughly speaking, that was the non-cessation, right? So when you want to have a more and more, the indifference curve will be downward sloping, as I had just explained, right? All right. So it's going to be downward sloping because if I take out some of the second good from you, then you want to be compensated by more of the first good, right? So so we can think of these slope. So all right, here's the slope. So here's a straight line. So this blue line is a straight line. So this is the slope is the rate of substitution. Right. So what do I mean by that? So say this is the 1 comma 2 and b was what is it? We used yeah, yeah. How come this is not getting smaller? Something sometimes happens. All right. Yeah. So I start with a 1 comma 2 and 2.1 to 1.5, right? Yeah. So this was 2.1 and 1 comma 5, right? So what is the rate of substitution? So in other words, sacrificing 0.5 units of the second good is equivalent to gaining more of the first good by 1.1 units, right? So 0.5 of the second good, 0.5 units of the second good is equivalent to 1.1 extra unit of the first good in a sense, right? To repeat, 0.5 units of the lost second good is equivalent to 1.1 unit of the additional first good in a sense, right? So we can think of this as a rate of substitution. So in other words, I'm willing to substitute 0.5 units of this first second good with 1.1 extra unit of the first good, right? So that's why this is called the rate of substitution. So I can substitute 0.5 units of the lost second good with the 1.1 unit of the extra first good. So that's why this is called rate of substitution. So right, so the rate of substitution is going to be 1.1 over 0.5. So that's like I know how much is this is 2.2, right? So the exchange rate, a kind of exchange rate between the second good and the first good is 2.2, right? So that's the exchange ratio in a sense, right? But of course, this rate of substitution will be different, right? So in other words, the slope of this blue line is the slope of this blue line is 2.2. I mean, to be precise, minus 2.2. But I'm going to often ignore the minus sign. So the slope of this straight line is minus 2.2. But But the slope will be different if you think of a different change instead of 0.5 units. So let's say 0.25 units of decrease. Then the slope will be different, right? So slope will be probably steeper. So it's not going to be 2.2, it's going to be larger than 2.2, right? So in other words, depending on where you end up, the rate of substitution will be different, right? So that's not really, let's say, convenient in the sense that, or scientific or objective in the sense that the rate of substitution change depending on where you arrive. That's not very ideal, okay? And also, it's kind of cumbersome to use it, right? So here, instead of this different slope for everywhere, we are going to use one particular slope, that is the slope of tangent line passing through 1.2. So that is okay. So this purple line is a tangent line at point A, right? And we're going to call the slope of this one as marginal rate of substitution. Okay, so the difference is only this extra word marginal. So instead of rate of substitution, we're going to define marginal rate of substitution. So in other words, instead of considering a difference of a chunk of difference, so moving from 1 to 1.5 is a move of a chunk, right? 0.5 is a chunk. But instead of this chunk of change, we can think of an infinitesimally small change, really, really tiny change. So I'm thinking about reducing the consumption of the second good from 2 to 1.999999999. Okay, so we're thinking of a small change. So if that's the case, the rate of substitution will be the same as the slope of a tangent line, right? And to signify this is very small change, we use the word marginal. So marginal means a small, insignificantly small, okay? So this slope is called the marginal rate of substitution, you know. So if you take the mathematics course in the first year, you know that we are using the calculus as the main tool for the economics, right? And what is a calculus? Calculus is all about the small change, right? We're looking at only the small change, and then treat the small change as if it's a big change, right? Because that's what we do in terms of differentiation, right? So when you differentiate a function, you get the slope of a function, right? So what is the slope? What is the definition of a slope? Slope means if you step to the right-hand side by one step, how much does height change? That's the definition of the slope, right? So of course, if you think of, say, a nonlinear function, all right, so maybe I used so if you think about this function from real line to real line, yeah, so let's say if you differentiate at x0, the slope is given by the slope of this tangent line, right? But of course, if you change from x0 to so maybe this is too much. Oh, yeah, maybe this is too much change. So let's say you increase x0 to x0 plus delta. okay, then the actual height will be here, but this is the height given by the tangent line, right? So in that sense, the slope doesn't give you the actual the actual change of the function values, but it gives only an approximation. But when we are using calculus, we are ignoring that difference, right? So we are treating as if the function is a linear function. So that's what calculus is about. Well, in the end, it doesn't really matter because we have this tool called integration. So if you integrate all the small changes back, then you can get the changes in chunk back, so that it's okay to use the differentiation. So that was the logic behind the calculus, right? So the same thing here. So in the real world, we cannot really change our consumption infinitesimally. We can change it only in chunk, but we're gonna treat individual choice as if the person can change the consumption infinitesimally small, so that we're gonna use this concept called the marginal rate of substitution. But in the end, it doesn't really matter because since we have this tool called integration, we can always get the chunk back later, right? Well, not that we're gonna use that much in this course, but I'm just saying that it's gonna be okay in the end, right? So anyway, so this is the marginal rate of substitution, all right? So we think of infinitesimal change of the certain goods consumption and see what happens to the infinitesimal change of the other good to be on the same level of happiness, right? And the indifference curve is a set of all the bundles that you're indifferent between, right? All right, let's take 5 minutes break and then I'll get back to you.